Welcome to TechLeader Voices, where we help enterprise decision makers navigate AI transformation. I'm joined today by Tim O'Brien, who is a technology veteran. So if I had to introduce Tim, I would say that Tim has had a very long career in enterprise architecture, spanning multiple Fortune 500s, including Google and HP. Has also launched 4 successful startups himself, including edtech startup ICanProveIt, which deals with skills validation using agentic LLMs and blockchain.
Okay.
Welcome, Tim. Would you say that's a fair characterization of your career so far?
Yeah, that's a good summary. Happy to be
Amazing.
here.
Good to have you. Okay, so the topic of our conversation today is going to be kind of mental models for LLM products, specifically around this kind of mental model that Tim has, which is determinism versus non-determinism. But firstly, before we kind of dive into the details of the mental model, just to set the context for our audience a little bit, when we were kind of brainstorming topics for this conversation, you had this kind of laundry list of mental models that you're ready to share with other leaders. So we just wanted to hear from you. What do you think is the value of a good mental model? Why is it important for people? And how do you use them to see the world?
Yeah, sure. So mental models are very useful, and they've been proven quite a few places. I think Charlie Munger has been made very good use of them, and Warren Buffett in financial mental models that help them succeed very much. And the other name associated with mental models is Richard Feynman, who's a famous theorist, and he wrote quite a bit about mental models. So they're very helpful. They kind of capsulize the decision-making process and give you different models or lenses to look at a problem. And what people has discovered is that when you have like 5 or so of these mental models, that the accuracy of your decision-making is actually exceeds the accuracy of somebody who has no mental model, doesn't use mental models. So they filter out a lot of bias, cognitive biases that we all have, and they also lay the groundwork for the analysis. And some of them can just be applied very quickly. They're very useful, particularly when you're dealing with very complex topics, as AI is, and especially when you have to evaluate new information rapidly. I think they're a perfect fit for AI.
Mm-hmm. And I know you have a mathematical background, right? So so do I, to be honest. So we'll both know the value of making abstractions, basically, as a way to kind of see the world.
Yeah. Mental models sort of came from science and then data science, and then kind of they made their way up to social science. So they're everywhere now.
Yeah. So just as I guess as a simple example of a mental model, you've written about red cape here. I suppose is that a mental model itself, or will it just kind of help us to describe how mental models work?
It sort of is a description of the advantages of using mental models, what they do for you. So REDCap is an acronym for reason, explain, design, communicate, act, predict, and explore. And these are the areas that using good mental models can increase your strength.
Okay, so if you were to just pick one of those kind of bits of the acronym and explain to us very briefly what it's about, would that help, do you think?
Yeah, sure. So I think explain, for instance, or reason. Charlie Munger used reasoning in financial systems, and Warren Buffett, he took from the big book on Graham on investing, very famous book, and he created mental models from that book, and he gave them to his analysts and used them himself, and he used them to analyze stocks. And we all know how successful Warren Buffett was. So that would be an example of a very successful use of a mental model.
So it's almost a heuristic, you could say, to help us decision make at speed.
Yes, absolutely. Yeah, that's a good description.
Excellent. Yeah, so that's a good introduction, I think, to the overall subject. So the actual mental model we're looking at today is the determinism versus non-determinism model. Would you just like to give us a high-level introduction to this model?
Yeah, sure. It's hard I think we all have sort of an intuitive idea of deterministic versus non-deterministic, but it's good to sort of go over it and get it sort of a deep absorption of what that means. A lot of times I think if you look at like 200 years ago, what would be a deterministic system? Maybe 300 years ago, back 300 years. But basically, deterministic systems would be largely physical systems. Like, for instance, gravity. You would know if you dropped a ball that it would go to the ground and the speed that it would be. They're really everything else, like the weather, like your interaction with your fellow humans, like would your crops come in, all that would be highly non-deterministic, and they're low predictability. And then a lot of the reasons that we have this determinism within our life, it came through technology. So the first technologies, even a car, say, they need to be deterministic. So things like if you press a brake pedal, then it goes through a number of deterministic components that result in the car brake pad hitting the wheel and the car slowing down or stopping. So that was kind of the introduction of sort of mechanical determinism. And then there's a long history around computers where, they came from the sort of a Turing process and their code where you explicitly say what needs to happen. And so we've lived for a few decades now with sort of computer determinism, and we've almost sort of associated determinism with computers. But now comes LLM, because LLM are part, and this is where I think a lot of people get confused a little bit, and that's that LLM are part of this technology. They're the leading part of the technology, but they're also, I believe, the first technology that actually is non-deterministic. So that is quite, clearing that up is one of the essential ingredients to making good decisions on where to use LLM and how to use them.
Okay, so when you say LLMs are non-deterministic, would you just make it really clear what you actually mean by that?
Yeah. The first definition, I think, is that you don't know the outcome. They are similar, like if you meet your neighbor, you say hello, you have no idea what will happen next, because humans are non-deterministic, right? If you get in your car and drive to work, you don't know what's going to happen along the way. So that's very non-deterministic versus something that is very prescribed. You know exactly what's going to happen. I think when you pick up your phone and make a call, you can say that's quasi-deterministic because you know all the parts are going to work and you're going to connect and talk to your friend on your phone. So a key, I guess it's a technical point, is when it's deterministic, it's testable. So you can say exactly what it should do, and when it fails, you can say that it failed to perform its job, and you can look and find the piece of code that actually caused it to fail. With a non-deterministic system like LLM, you don't know, and we're not talking about hallucination here, we're just talking about the interpretation. If you ask a question, you don't know what the LLM will respond with. There's certain other like subcomponents of determinism, like you don't know necessarily the tone, as well as the information, as well as how much information. So this is very non-deterministic, and also from a computer science perspective, you don't have error. You can't define errors because you can't define expectation. You can see something and say that a response and say that wasn't expected. You can't say it was an error because there might be somebody else who saw it and thought that, that's exactly what I wanted to see. So that's another key difference, that with LLMs, you cannot explicitly define errors the way you can with a deterministic system written with code.
So what do you see are the main implications of this observation?
Well, I guess on the one hand, I see a lot of applications of LLM that probably are very faulty.
Mm-hmm.
There are places where LLM doesn't really work. We're now in sort of this manna where everything about LLM is accepted and considered wonderful. But I think we're beginning to see companies coming back and saying, well, we spent a lot of money. All we got was headache.
Mm-hmm.
It's possible for an LLM when introduced into a deterministic system, to completely mess with your entire system in some very bad ways. On the other hand, non-determinism is great for talking to humans, because we're non-deterministic systems. We don't always like to be talking in binary, yes, no, or we like a dialogue, and they can communicate information to us as fellow non-deterministic systems. They can customize a lot of very good information and actually raise the bar on what computers can do. So the good and the bad.
I see. So there's a short blog post that you've actually written on this topic. In your blog post, you have this nice kind of set of two Venn diagrams where you've got like overlaps between the deterministic world and the non-deterministic world, and kind of pre-LLM, the overlap section is quite small, and post-LLM, the section is much bigger. I'll put these diagrams into the blog post and like on the video as well for people.
Okay. Awesome.
But could you talk us through kind of what these Venn diagrams mean kind of for the world?
Yeah, you can think about different ways that you can combine deterministic systems and non-deterministic systems. So, I mean, the obvious one is like the non-deterministic to non-deterministic, and this is our legacy software is captured by that. And you can have, deterministic to deterministic is our legacy software. Non-deterministic to non-deterministic could be considered like our communicating with our chat apps or LLM. But I think where it really gets interesting is where you combine deterministic and non-deterministic systems. Because and this is one of the first models, that when you add non-deterministic component to a determinist system, you have to consider that system as non-deterministic. So this has a lot of implications. Obviously, software engineering has a lot of interest in reliability, so this completely changed the climate of the climate of dependability, and also it introduces a lot of new possibilities, because now we have something that can adapt to humans, communicate with humans, but it's something that has to be done with a great deal of caution.
Yeah, so this caution aspect, we can dig in a bit deeper, right? So in your kind of first rule of thumb that you put here, you said that, yes, as you said, adding a non-deterministic component to a deterministic system makes it non-deterministic and should be avoided in most cases. Yeah. Could you expand on that? Which cases would this advice be relevant to, etc.?
Well, if you're adding a component to a system that existed, before, let's say, 2020, then it's probably deterministic, and probably deterministic for a reason. Mm-hmm. There's probably an assumption that users have certain expectations that have to be met, and the system has been designed in order to deliver exactly the outputs, whether to the customer or to another component or element in the architecture. So now you all of a sudden introduce non-determinism in here, and you cannot really say for sure what the output will be. So in the sense that you're sort of changing the expectation, changing the contract with other systems and with the contract and without careful thought, that's usually a very big mistake.
Yeah. That makes a lot of sense. Yeah, so this kind of ties in with your idea of the basic idea of testability, I guess. So you've written here, doing this kind of thing means the system will behave in a way that you don't expect, but you won't be able to test it.
Yeah. In fact, you can't really say that it has an error, because a non-deterministic system cannot be defined. You can't really define what is an error in a non-deterministic system. So now your whole system, really, you cannot define what is an error from that system from the perspective of the roll-up of its components.
So how would you approach testing then if you say you integrated this LLM, but there are these issues about fundamental undefinability of an error?
Yeah, I mean, you can define in terms of human expectations, right?
Right.
You can say it disappointed me or it didn't disappoint me, or it's really good or it's really not good. That's very different from deterministic testing, where you say its response was X. And it's also very subjective, because you have to ask, for who is it disappointing, right? Or for whom is it disappointing? Because I can be a product manager and say, I didn't want that output, but it might be there are many people who think that output is fine, and vice versa. So then you have a very subjective criteria on good behavior versus bad behavior.
And is that a good thing, you see?
It's a
Or
very powerful, but like anything powerful, it can be very destructive or lead to very creative products. So so depends on how you use them.
it does seem like this kind of, I suppose it would encourage a move away from a kind of, as you say, a more objective tests and towards kind of subjective assessment, which I can see being quite dangerous.
Yep, sure.
Okay, so there's this second rule of thumb now that you've mentioned to me, which is, do you remember it or do you want me to go through it?
Let me think. I don't
That's
remember
okay.
the order. I think when you start using deterministic systems and the results go to somebody who doesn't know you're not using the non-deterministic system, that's a very bad combination. And I think in some of our other mental models, we'll see that having LLM reproduce exactly what we would want to say or what a human would want to say is not really possible. So I see a lot of possibility for problems here. First of all, it's kind of like, okay, from the get-go, is it kind of really the right thing to do to generate something and send it in email to somebody and sign it as Joe or make them think a person sent it, and then the interpretation of that message the user should be allowed to know the source of that message and interpret it as a machine generated message. So that's, I think, an important rule.
Okay, so the rule, just to restate it, right? It's ask if users who are interacting with non-deterministic systems know they are using a non-deterministic system. If the answer is no, and if they would not use the system in the same way if they knew, then it's not a good system.
Yeah, exactly.
So you're saying that, so in that example, if the user knew that the email they were receiving was generated with the help of an LLM, they would behave differently, is what you're saying.
Probably. They'd probably send it to the garbage.
Okay, I see. So have you seen this kind of thing happen in the real world?
Yeah, I see it everywhere. Particularly today, there's kind of a fad where we're looking at automation. We have these cool tools like MCP, which allows us to connect to many components. And so there are hundreds of these applications that will connect to your Facebook, connect to HubSpot, or connect to your email, churn things, find out, go out and look at a LinkedIn, investigate a customer, and then send that customer an email. Or similar within an enterprise, you have like LLM will analyze a lot of messaging from users, and then they'll generate them a notification of a discount or maybe send them a bill. So these kinds of systems violate that precept. So
Right, okay.
I think probably to be avoided.
So for your example of if it's just the customer is being sent a bill, where is the harm in that? Do you see? Why would you call that not a good application?
Well, firstly, there could be errors in the bill in the calculation. The customer has to depending on you, on the brand, on the selection of employees and such. And now you're probably cost savings. In your cost savings, you have to do some kind of mental calculation. Well, we'll send the wrong bill to maybe, 1 out of 500 people, but then we'll figure that out. If they find it, then we'll sort of figure it out. So there is an element here now where if you can compare the error rate of the LLM versus the error rate of a person, and then you find the error rate of the LLM is equivalent or less, then maybe you can bend the rule a little bit. But still, I think it's a solid rule because it's something we can get into later, but LLMs are really not equivalent to human reasoning. They never can be. So you will always have a certain risk, and you will always have a difference between human output and LLM output.
So this is touching on now your insights versus algorithms model. Is that correct? Okay.
That's correct, yes.
Do you want to insert 2 sentences in this conversation about that, just since it's related, and then we can go back?
So I mean, a lot of people are saying that we will have AI that will be equivalent to a human in their thinking and in their output. And actually, and it's a long story, but actually this topic is not new. This has been around for a couple of decades, and it's been addressed by logicians. Gödel was one, and it's been addressed by physicists. It's been addressed by psychologists like a long time ago, and they've gone beyond just making claims. They've actually, in the case of physics, and in the case of logic, they have very uncontroversial theorems that show that the world of computers can never go beyond the computational world, and the computational world is a small part of our world. So humans are able to transcend beyond the computational world. And we do it quite often. And Georg Cantor was a mathematician who sort of put up a prize to prove if this could be true. And yeah, we have a massive amount of information, or we have the Mount Rushmore of science who would say this can't happen. On the other hand, we have the computer scientists today who are very eager to say this is on the way within 4 or 5 years. So that's a very interesting topic, and one that I think really everybody should know, because it not only like answer the question, what should I do with my life? But like, what does it mean to be human? Are we just meat computers that can be replaced by silicon computers? Very important to industry leaders, because they have to decide, whether they need to start preparing already for a world where computers can do everything that we as humans can do.
Great, there you go. In a future episode, we will cover more on this subject from Tim.
Yeah.
So back to this determinism conversation.
Yeah.
So this we touched on this topic of, I guess, safety and reliability. When do you think we must protect determinism?
I think in the vast majority of cases, and by that I mean the vast majority of software. Today we're putting software everywhere in spreadsheets, are run by LLM. I think a lot of internal systems of enterprises are being converted to LLM. Microsoft is moving all of its tools to LLM. I think this is a big mistake. These systems were originally designed as deterministic. We as users expect determinism from them. And now we're sort of dealing with elements of non-determinism, which I think is unfair, because a lot of especially the people who they expect this determinism, but they haven't really grasped yet the nature of non-determinism. And maybe we need, in order to implement this, we need to make a calculation that, this will go wrong quite a few times. I don't know, 1%, 0.01%, but this will cause problems, 0.01%, but it's worth doing it because we'll get more customers by making it more convenient. So I think that's a bad calculi.
And this transitions us, I think, nicely into the third rule, which is ask what happens if a non-deterministic system produces unexpected outputs. Avoid systems where the final authority is an LLM process.
Yeah, I think if the result, if it's a human-assisted tool, then I think things can work quite well. And I think there are a lot of products yet to be built that help people become more efficient at their work. And an example that I have would be, I was looking at the customs systems, and they set up AI to look for, I don't know, bombs, guns, whatever, going through the conveyor belt. And it turned out people get really bored just looking at the machines, and their error rate is very high, like 50. They miss 15% of them.
That is high.
So if you introduce AI can pre-process that and find out like the odd looking things and reduce from thousands to maybe 2 or 3 an hour, and then a person can go and look at that. That's an excellent synergistic system between humans and AI.
So yeah, in terms of this kind of never reaching a final decision on their own, you talk about this synergy with humans. Is that the only synergy that's possible here? Does that make sense as a question?
Let me think about it. Is it the only synergy? I mean, there can be synergies between LLMs, and there could be synergies between LLMs and deterministic systems.
Yeah.
But as we mentioned, the latter has very high risk. So you have to be very careful. You have to look that you're not that you're on the periphery of the deterministic system, and there's no inputs from your LLM that are then going into the deterministic system and mucking things up. And if they are, then you're prepared to say, tell your customers that your entire system is non-deterministic, which doesn't make sense because you probably put a lot of money into building it and testing it, so it's highly deterministic.
Right. Okay, that's a great answer. Thank you.
Sure.
So something that I asked you as well, if you think about, again, those combinations of interactions, so it's, deterministic and deterministic and non-deterministic, and then the other two, which one of these kind of combinations excites you the most, and which one scares you the most?
For sure, the non-deterministic to deterministic, and particularly when it's ordered, as we mentioned, a lot of automation systems, because determinism can actually be compounded. So if you have a system that's going out to Facebook, analyzing it, going out to your email, analyzing it, going to a local database, analyzing it, and then constructing a text or an email, then you have actually, like a much higher chance of that saying, having brand damage because you sent the wrong email to the customer. So those are for me, the most scary systems. I think on the other hand, LLMs they're just so powerful. They can research, much, much more than a person could do in a lifetime. They can do in a very short time, and they can set up hypotheses, and they can set up arguments, and it's just extremely powerful. Those systems where you use LLM, it's non-determinism, and to gather the information, to perform certain tests on the information, and then produce a result. They're very valuable, although they usually come through, you get that just by interacting with the LLM. So the products that sort of wrap that process around in a convenient wrapper that saves data, that sets things up, that prevents you from having to be an expert prompt writer, those products are also becoming extremely useful and likely to really increase global productivity and make our lives a lot better. Both sides of the spectrum. We have a case where we could just overuse them without giving proper thought and then end up in really bad shape, or we have the well thought out products that could really, really benefit mankind, womankind.
Thank you for that. So this kind of profusion of LLM wrappers, I think I've kind of seen a lot of these startups and just tools floating around. Can I ask which ones you use yourself?
Well, I use ICanProveIt.
Of course, plug.
I use a tool to create websites, web pages, which I find totally awesome. So anybody can upload. It's called Fresco. Spelled with a K, fresco.ai. I won't say anything more about it. There's a lot of information, a lot of things go into creating a good website. It's not just the technical coding, but it's also good copy, selecting the right images. And they're just it's a little bit of a disadvantage for small businesses because if you could go hire a big advertising team to build your website, you get a lot more customers, you have SEO optimized. But if we have, the small mom and pop store can spin up a website just by uploading some information about themselves, then that's pretty awesome. So that's another tool I use a lot.
Brilliant. Thank you. So if we could move on perhaps to really anchoring the discussion about mental models in terms of addressing who can actually benefit the most from applying them. So who would you say this mental model is most suitable for? Who is it kind of mandatory for, and who would it just be helpful for?
I think anybody making decisions today on use of AI, particularly if, right now AI is critical to being competitive for all industries. So a lot of A lot of executives have to make a decision of when to dive in, how deep to dive in, which technologies to adopt, and what to wait until the next phase. These are very critical decisions, and they're very challenging because we have really drinking from a fire hose now on all the information. And these are not just like news items. A lot of these are transformative in the technology. So one approach you might have decided a month ago may not be the best choice today. So executives are facing really, really tough challenges. The mental models are really very, very useful for this because they can be used as a process. So basically, you want to have a store of 5 or 6 mental models, and you want to apply these to make your decisions. And then the results of using these mental models can help you process a lot of information very accurately and come up with very good decisions. Using, I guess, statistically, it's been shown that when people use multiple mental models, they make much, much better decisions. So I think, I can't see any executive that wouldn't benefit from using mental models.
So kind of, if you look back in your career so far, at what point did you become attuned to the need to have these kind of mental models explicitly, if you remember?
Well, it was actually the advent of, I'd been aware of them for a while. I used to like to read Feynman books. He had a famous book, and he was a big fan of mental models, and I'd tried them out before. But being in computer science and in this age, when you have so much information, I feel like I wake up in the morning and I just start reading, the new developments in AI. Each one of them more exciting than the last, and there's also a lot of cruft in there. There's a lot of false claims. There's a lot of products that are just trading off the reputation of AI, and I need to make a lot of decisions. And for me, learning everything I need to know about AI and then applying it, that would be a full-time job for someone. So I had to adopt mental models. So about 2 years ago, I started building these mental models that help me make decisions around AI, and both product decisions and marketing decisions and adoption decisions.
Is there any single model that you use more than the others?
For now, insights versus algorithms is I think the others are highly, highly useful. I think this model is a complete breakthrough because if you can if you can fathom the limits of AI and how far they can reach, how far they're capable of reaching, then that's a view into the future.
Okay, so again, to ground the kind of the kind of this kind of abstraction into practice again, you've written the best way to use models is to just keep a list of them written down, and when new challenges arise, apply each model one by one to the challenge. Yeah, I guess that kind of speaks for itself. But do you have anything to add to that?
It takes some discipline. I have the mental model list on my monitor, a list. I have to make that everything. And then if I have a question, it's a process. I apply the model to each of the decisions I need to make. And then I look at the aggregate result.
Okay.
It takes about 15 minutes.
That's not very long.
Mm-hmm.
Yeah. Okay, so if you could entertain me, could we walk through an example of either like a time recently where you did this exercise yourself?
Yeah, sure.
Yeah, maybe we could go with that.
I mean, I'm always tempted because as a company owner, I'm thinking about marketing. How do you reduce marketing? You always have the problem you waste a lot of money in Google Ad or ads, online ads or whatever. And there, I don't know, 200 products that are saying, well, we'll automate this process for you. We'll find your customers on LinkedIn. We'll write the perfect sales letter, and we'll either post it to the LinkedIn or find their email and automate it, the email. So you have a very deterministic process where you sort of want to route and you want to say, get this information and then move it to the other part. And then you have multiple non-deterministic systems, which is analyzing the data with LLM, summarizing the data with LLM after each call, and then creating an email for the user or sales letter. So this, I guess, violates a lot of the rules. I mean, primarily, you're now mixing a deterministic system, which is the routing, what information do you get, and then what information do you include in your letter, with extremely non-deterministic information, which is interpretation of Facebook posts and emails and generating the email. And then on top of that, you're sending a sales letter to somebody who thinks that you send it personally or your company sent it. Anything that is odd about it will reflect badly on the company. And for me, my reputation is very important to me. So, even if 1 in 500 emails has some blemish, non-human blemish, I think that I would not want to go with that solution.
So what kind of is the consequence to applying this model now to make this decision?
For me, it's a very clear consequence that I wouldn't use that product.
Okay.
Yeah.
Okay, got you. Yeah.
Okay.
Okay. So that was one example. You also have a few other bullets here where you think it may be applicable. You've written identifying the highest value use cases, long-term planning, and finding new innovative solutions. I guess the third one was kind of what we covered.
Yeah, I mean, once you get in the enterprise, then there's definitely a formal process for identifying the best use case. A lot of companies now may have done a POC, but they have a budget to do some AI. Some are serious about it. Some are creating more elaborate POCs. And then a lot of these may actually reflect on the future of the company, how much trust you have on the AI. So if you go out and you push, create put the LLM in with your database and your payroll and your inventory management system, and it mucks everything up, that's going to be a very negative thing for AI adoption in your company. So applying these rules inside your company is also very valuable.
I got you. And then just a question about, I guess the right question you should ask with every model is, where do you think its limitations are? Where does it break down?
Well, mental models, some mental models are, I would say, stronger than others. They are more persuasive than others to a certain perspective. An error, obviously, would be to choose the mental model that sort of agrees with your initial assumption. The best application of mental models is to apply multiple mental models, because each one providing a lens and a view into your decision. And then it's been shown that where one may be wrong, they kind of offset each other. So having multiple mental models and applying them all is much more accurate. So using them in a limited way, I think, could get you in trouble. Relying on them is also something. You should always just be persuaded by them, not just accept whatever information provide. So those caveats.
Of course.
Yeah.
So use them as part of a wider package of analysis. Yeah. And this kind of theorem you keep referring to, it's called the diversity prediction theorem. Is that right? That's what you've written down?
Correct. That's correct. Quite remarkable. But it's been quite, it's proven that, the proof there is quite good. That the use of multiple models drastically increases your decision accuracy.
Perfect. We've actually made really good time.
Really? Okay.
So I wonder if there's anything that we haven't covered that was in our planning or we talked about that you'd like to cover now.
More about algorithms versus insight?
Do you want to? I can give you 5 minutes if you want.
Okay. Yeah, please.
Yeah, okay.
You want for the next section.
Yeah, there we go. Okay. We'll tease the next episode. Right. So do you want to introduce your next model, insights versus algorithms?
Yes. So I think one of the most critical challenges today, or questions today, is just how far can computers go in emulating humans? Can we have consciousness? Can we reach AGI? I think this is very critical for a number of reasons. Obviously, if you're a business owner or a CEO, If the answer is affirmative, then you have to start thinking of a completely different world, depending whether you agree with Elon Musk or one of the other experts. It could be in 4 years or 10 years, but it's not too early to start planning for another world. But I think it has a much more profound and deep impact, on that if computers can become conscious or have consciousness, then comes the question of who are we, right? When we ask this, we're not really asking about what are computers to do. We're really asking who are we. And I think it would be a very big shame if the whole world thought of ourselves as, I didn't coin this word, but meat computers that will highly inefficient. And that goes against that contrasts with sort of whatever faiths we believe or philosophies we have would be completely transformed. And maybe we would view each other and ourselves a lot different. So I just sort of stumbled across this fact that the limitations of the computer versus what humans can do is actually not in the domain of AI at all. This is something that there was a famous logician, Gödel, he addressed it. A mathematician, Cantor, addressed it. A lot of physicists addressed this. This is a problem that had intense concentration by the world's greatest scientists for 2 decades. And the conclusion they came to all uniformly is that there are things that humans can do that computers could never do. And they're based just on the fact of computability. So it's hard to say, but computers, because of their nature, they can only do things that are algorithms. You can give them a formula, a set of steps, let them choose the steps, but there are many things that they cannot do outside of this. So that leads to the question of what percentage of the universe is actually computational, because if it can be done with algorithm, then it's computational, versus what is possible outside of the computational world. Is there something outside of the computational world? So just as a preview, maybe for the next section, the answer is that all of sort of, you might say, the list of the most respected scientists and logicians and mathematicians and even computer scientists come down firmly that the world is not computational, which means that we as humans are unique, and which, if you're a corporate executive, means you really would be using a lot of money, throwing money away if you're planning on replacing everybody with computers. So it had profound implications. It really, anybody starting out in college wondering what to study, this would be really inform that decision in incredible, very turning point decision for them. And just sum up, but if you just like to imagine there's a debate between this Mount Rushmore of scientists, mathematicians, physicists, versus today's AI computer scientists or AI scientists, the weight is entirely on the side of the world not being computable. And it's a debate that, like, a century ago, everybody would be engaging in this debate. Everybody, the computer science, AI scientists would actually have to disprove the prior theories before that they could go out and make claims to the contrary. That just makes sense. So we have exactly the opposite. Computer scientists, they had massive computes. Before they had these massive computes, they kind of doubted themselves. They don't know really why their systems work. Even they're in no state to debate with, the Mount Rushmore of science and mathematicians. So I think that's important for everybody to know. That's, I felt a load off my shoulders when I started reading that. And when I started really I'm not a meat computer, I'm a human being, it lifted a burden. And I think there's a lot of people in this world suffer from that burden. So, I would like to spend time getting that message out. And I also think it's critical for anybody making computer decisions today. That's where sort of algorithmic versus insights. Insights are something that we as humans can make that computers can't achieve. So the world is breaking down between algorithms and insights, but algorithms are a tiny part of the universe. So no worries.
Thanks, Tim. That's a fantastic way to wrap up the episode, I think.
Okay.
Would you like to tell us a bit now about what you're working on at the moment and where people can reach out to you if they have any questions?
Yeah, sure. So my last startup, ICanProveIt, it's going to be renamed, but it's being resold. Fantastic news for. I was very happy to get this because I no longer have to maintain the product fully. I don't have to run a sales staff. The reseller has connections everywhere. They have a line of first line support, so I can kind of relax a little bit. I started working with a company. I think I referenced it a little bit. How to generate websites very quickly. I think it's going to be a really great thing if people can get an online presence that competes with sites that have professionally copywritten and professionally designed, but they don't have the budget to do that. And also continue with my company Fuixlabs, which is both a consulting company, and I often use it to spin out my own products and prototypes to test the market, and then use it to build it. But I'm continuing to work with Fuixlabs, and anybody who wants to connect me can go to the Fuixlabs website, and you'll find my profile and my email there.
Brilliant. Well, I think we can wrap up then. That was a fantastic conversation, Tim. Thanks so much for your time. And thank you for joining me, and watch out for Tim's next episode on the insights versus algorithms mental model. Thank you, Tim.
Awesome. Thank you.